How's it going today, guys? This is Jason Seigal. You know me by Calculus with Seigal. I've been around a few times, taught you some lessons. I'm going to teach you another one today. Today, I'm going to teach you a popular topic that many people struggle with in calculus. In fact, it's one of the most difficult integration techniques. It is called integration by parts. Now there's a key formula that you're going to have to memorize. So I'm going to write that down first, and if you're taking notes on this video, I suggest bolding, highlighting, whatever you need to do. So we're going to be integrating. It's similar to the product rule when you're differentiating. Same idea, two functions being multiplied together, except this time we're integrating. So it's going to be, I'm calling this u of x. This is v of x. Now u and v look very similar, so I'm going to mark my v's by a line through the middle, if you can't tell the difference. So we got one function, two functions. One's going to be called u, one v. So here's the formula. U v minus, remember the minus, the integral of v du. Now you probably think I'm crazy right now, but I'm going to go into detail. You're going to understand this. Here's an example. We're trying to integrate x times the sine of 2x. Now, u substitution wouldn't work here, because if you made your u 2x, your du would be 2, and there's another x here. So it's similar to the product rule, but we're integrating. So this is what we're going to do. We're going to call this first function u. So u equals x. The reason I made this u and not this u is because when you're deciding what to do, you always want to make the u something that is going to eventually continue to derive to 0. So right now our u is x. Our du, which is simply the derivative of u, is going to be 1. I know you can do that. Then our next function is going to be known as dv, so the derivative of v. So I like to put that here, equals the sine of 2x. Now, we already have the derivative, so we need to integrate this to find our v. So to integrate sine of 2x, it's going to be negative 1/2 cosine of 2x. So now that we have everything labeled, we can now plug it into this formula that we wrote up here. So we did all the hard work, now we're just plugging it in. So u times v, so that's going to become negative x over 2 cosine of 2x. So that's our uv. We're going to subtract the integral of v du. So minus the integral of v du. So it's going to be negative 1/2 cosine of 2x. So right here we got u times v minus the integral of v times du. So it just becomes v because du is 1. So now we're halfway done here. We just got to integrate one more time, but as before, we couldn't integrate. This time, this is a simple integratable function. So let's not forget what we're originally trying to integrate, this right here. So we're integrating x sine of 2x equals uv minus v du. We already wrote uv here, so it's negative x over 2 cosine of 2x minus the integral of that, which will become negative 1/4 sine of 2x. If you need help integrating, that's a different story. I'm just trying to go over the integration by parts here. So we'll clean this up a little bit. It becomes negative x over 2 cosine of 2x. Double negatives becomes a positive. Simple. You know this. I know you do. Sine of 2x. And that's the answer. Now, sometimes your u isn't always going to be as simple as x. So when you go to derive it, it'll be, so say it's x squared, you're going to have a du of 2x, and you're going to have to do integration by parts twice. Rather than do that, I'm going to show you a shortcut that can be applied in almost every situation. It's called the table method. So we're going to make 3 separate columns. One, you're going to label the sign, not the trig function, literally the sign. Then we're going to call this u, and we're going to call this dv. So I'm going to give you another function here, x cubed sine of x. So if you were doing this based off what I just told you, x cubed is the function that's going to go to 0. So we're going to call this u. Then our sine of x is going to become dv. Now the sign is simply going to rotate back and forth. So it's going to start at positive. Every time it will start at positive, no matter what's here. So now this is what we're going to do. In this column, we're going to be deriving. And in this column, we're going to be integrating. So we're going to derive this until it becomes 0. So x cubed, 3x squared, 6x, 6, 0. I'm going to make little columns to keep it organized here. The sign, what I tell you earlier, it's going to be alternating. Plus, minus, plus, minus, plus. Now over here, we're going to be integrating. So our first thing is the sine of x. Integrate that, you get negative cosine of x. Integrate negative cosine of x, you get negative sine of x. Integrate negative sine of x, you get cosine of x. Integrate cosine of x, you get sine of x. Now that's all the heavy lifting. We're simply going to apply our trick now. In this problem, which you would have had to do integration by parts 3 times, can now be done very simple. So we're going to attack across and down. That's what you're going to remember. Across and down. So we start with our sign. We go across to x cubed, down to negative cosine. This looks confusing. It's going to be simple. Across and down. Across and down. Across and down. So now we get everything attached. This is what we're going to do. So we get our sign. Alright, so our first thing is positive. We get x cubed times negative cosine of x. So that's going to become negative x cubed cosine of x. Now we go down to next. We get a negative sign. So it's a negative 3x squared times negative sine of x. That'll become positive 3x squared sine of x. Then we're going down to the next one. We got a plus 6x times cosine of x. So we're going to add 6x cosine of x. Then we go down. We get a negative 6 sine of x. And what you thought was not integratable now is simple. So lastly, that first problem I showed you, it was x sine of 2x. You can do it either way here. You can set up the u, do it here, uv minus the integral of v du. Or you can use the table. The table's not always going to work. This is more sure-handed. But if you're cutting time on that AP exam, look for the table method. This was Calculus with Seigal. I hope you guys enjoyed. I mean, I'd love to see you again, so keep watching the videos. Suggest us to others. Thank you.